Okay, I just wanted to go through a quick review of case study 3. This has to do with Susan working in let me get that, there you go, the Agony and the Ecstasy. All right. So Susan is an intern at a hospital, and a man and a woman bring another woman in, and she's sick. They don't know what happened. She's acting weird, and so they couldn't wake her up. So there's a couple things in there that you're going to want to observe, and then Brittany's. They say, well, Brittany took some ecstasy last night. Whoops. And drank a bunch of water. I think that comes out a little bit later. But anyway, Susan orders several blood tests or a blood test to look at several items. So we'll look at those as well. So I just wanted to do a quick overview. You guys have all read this or you're going to read through it, but I really just want to go through a couple of the questions that discuss what some of mainly osmosis and how particles move and kind of what we see on the cellular level. So anyway, this grid or graphic is just showing the number of ecstasy mentions in the emergency room from 94 to 99. You can see a huge increase. Um, Geez, that's over 20 years ago now. I'm sure it's similar, although we're having other issues in the emergency room with opiates, but still we're getting MDMA or ecstasy coming in as well. So anyway, it talks a little bit about what MDMA is and why it's harmful and what it can affect: blood pressure, pulse rate, body temperature, water balance, hydration, dehydration, or excess water. So water imbalances. So again, it just depends on what's going on. So we run Brittany's blood, and everything looks okay, except for a couple things jump out at us. We see her heart rate's a little bit high, but it's in the normal range. Blood pressure also in the normal range. Body temperature just a little high, but you know, we can work with 100 body temperature. Glucose looks good. Sodium looking pretty low outside the range. We see the same with potassium and chloride ions. Oxygen, carbon dioxide levels look good. So those are all pluses, but we do need to get something going here with Brittany. So anyway, what's going on? Is it high blood pressure, hypoglycemia, hyperthermia, hypothermia, excess water? We also call it hyponatremia, so not enough, a condition of not enough sodium. So anyway, yeah, water will rush into the cells. We'll see aquaporin, little pores that water can pass through, opening up. So anyway, it asks a series of questions as well. It gives you a couple more items again that you can read. Diffusion and osmosis. The key to all of this is that particles generally are going to try to establish and maintain equilibrium. They still may move around, but that equilibrium from outside the cell to inside of the cell is perpetually trying to be maintained. So generally, we're going to see a 50-50 split. Its movement is random. So keep that in mind for later. Movement is random. So probability it's going to go to one side or the other is just like flipping a coin. It's a 50-50 chance. It's either going to stay on one side or go to the other side. And that is random regarding a particular particle. When we have a bunch of particles, they're going to move around randomly until they've established some sort of equilibrium. When too many are on one side, they get crowded. A couple will randomly move over to the other side of the membrane to again, and water will chase molecules. So water chases substance that dilutes it. So that's the osmosis part. If we have excess substances on one side, we can also just dilute that area and dump a bunch of water in there to try and maintain or establish an equilibrium. And again, you're going to want to watch the videos that I have on diffusion osmosis. You're also going to want to go to the Padlet. There are some items in there that'll be helpful. How these molecules behave over time due to random movement. At this point, the rest of the case study, there are a couple of links in here that I put that you can also click on that will be of help as well. But anyway, the Padlets have links or videos on it, and then my videos as well. You can certainly watch those. But I'm going to move over to the questions. The rest of that case study is mostly questions. So when we look at these questions, the first 6 or so relate to Brittany, and then the last 5 or so questions are just more general with diffusion and osmosis. Okay, so again, we're looking at everything looked pretty good, but sodium levels were a little low. Hyponatremia, we'd say maybe too much water. Hyper hydration, too much water. Again, we're looking at a 50% or 50-50 chance. And again, if I have 10 molecules on one side, 0 on the other, the idea is we're going to see 5 move. So we get 5 on each side of the membrane. Okay. And then number 4 asks about the molecules behaving over time due to random movement. Again, they're going to move randomly until we're equal of red and blue on both sides. And then moving through a membrane, again, water is going to move fast, right? It's going to dilute. It still has to go through pores to do that. Gases generally move a lot faster. So we see oxygen is going to move the most rapidly, or really with the least amount of difficulty. So water moves very easily through a membrane, but oxygen even easier. All right. Brittany's cells inside 300 millimoles of salt, outside 250. Again, water is going to go where there's a higher number, more concentrated. So water will rush into the cell. It's going to continue moving in both directions. So don't think that water's all of it's going to go in and dilute. We're still going to see movement back and forth from outside to inside, but we will see more moving to the inside, again, to dilute that area. All right, and then the rest of these are just kind of general questions about particle movement. 7, again, think of it as being random. Everything's random, but we do see high concentration to low concentration movement. Okay. Number 8 talks about what you would expect to happen if we continued to watch what's going on. They're going to continue moving around. Okay? Again, it kind of randomly. Molecules, they won't stop moving. Let's see, this gets down to, let's see, when we want to know whether a specific molecule will pass through a membrane, we need to consider, really, we're getting into whether it's water soluble, to what degree that molecule is going to be water soluble. Actively repelled is a lot of students pick C occasionally. There is no active repelling. The lipid layer of the cell membrane is passive. So sodium ions crossing a membrane, remember, they need help, right? They get helped by proteins. And then finally, number 11, similar to what we saw with Brittany, but this time the concentration of solute is higher outside the seawater is higher than the fluid in your body. So we would see water entering and leaving the cell, but more water is going to leave. Again, it's going to go towards the higher concentration. So that's it. That's all I really had for that case study. Again, go through it. I know you'll put a little more into understanding Brittany's cause and what's going on. But again, I don't want to spoil too much of your own fun and research as you're doing these. And again, if you have questions on any of these, please email me.